welcome to my presentation. My name is O-ono. Today I'll be making a presentation of human immunity. My grasp of non-specific defense against disease, specific immunity, and vaccination will be illustrated in this presentation. Infection. An infection happens when bacteria enter the body and multiply, resulting in disease, organ, and tissue damage or sickness. The four main causes of infection include bacteria, virus, fungi, parasites. Virus smaller than bacteria. Viruses are not technically living on the as they must locate a host to reproduce. From the common cold, herbs, and the flu to HIV/AIDS, they are source of several illnesses. Fungi. Numerous skin surface conditions such as athlete's foot are caused by fungus. The neurological system and lung may potentially be infected by them. Parasite conditions like malaria, which is spread by a mosquito bite, are caused by parasites. Bacteria, cellulitis, strep throat, UTIs, tuberculosis are all brought on by bacteria. Bacteria can enter the body through food, drink, soil, or air. Pneumonia, bronchitis, and ear infection are typical bacterial illness. Mode of transformation could be direct, indirect, droplet, airborne, facial, and oral. Animals to human. Animal to human could be, for example, animal's feces or urine, or animal scratch. The animals could include both domestic or wild animals. And then human to human could be a direct contact like handshake or kissing or sexual intercourse, etc. Indirect contact could be maybe when someone opened the door, an infected person touched the door handle, and a healthy person who did not know later touched that handle, can also cause this problem. Mother to child can also occur through breastfeeding. Non-specific defense against disease. General disease fighting mechanism, physical, chemical, and adaptive physical response are among the innate non-specific defense. The first and second line of defense are categorized as non-specific response. There are natural defense that are efficient against a wide variety of disease and external objects. This first line of defense, physical and chemical barriers serve as the first line of defense against pathogen invasion of the skin and mucous membrane. The barrier includes the skin, mucous membrane, cilia, chemical barrier, other body secretion. The skin, the largest organ in the body, protects interior organ and infection. The skin, which form a mechanical barrier that is impermeable, is the body's first line of defense against pathogenic microorganisms if it is intact. If it is cut or grazed, it immediately begins to heal on its own, typically by forming a scab which protects against infection. Since the skin acts as a physical barrier, the body lacking skin have additional protection against infection. For instance, tears from the eyes include enzymes which are chemical barrier. The palm and sole of the feet are the thickest skin, while the eyelid have the tiniest. Physical protection from the outer environment provided by the epithelial lining and skin. The skin has three major layers: epidermis, dermis, and subcutaneous layers. Mucous membrane. Mucous membrane, which cover the surface of many organs like eye, ear, nose, sinus, mouth, throat, gastrointestinal tract, respiratory tract, urogenital tract, vaginal tract, and digestive tract, are another illustration of physical and chemical barrier that make up the first line of defense. The fundamental interface between the internal and external environment. Mucous membrane serve as barrier between infection and internal organ. The interior system that immediately capture infection by secretion mucus through mucous gland are lined by mucous membrane. They permit wholesome nutrients to pass while blocking the entry of infection agents like infection and poison. Second line of defense. Varieties of general answer make up the second line of defense, including inflammation. It's a physiological reaction that raise the white blood cell count at an infection site. Fever and a rise in temperature intends to suppress bacteria development and speed up immune cell activity. Phagocytes are large white blood cells that take in foreign substances such as neutrophil and macrophage. A variety of blood protein known as complement protein help to break down infection and ultimately remove them from the body cytokines. Tiny protein with addition activities that prevent viral proliferation. Third line of defense. As the body's third and final line of defense, immunological response to infection and antigen try to destroy microorganisms that immune system has previously encountered. Antigen are substances that warn the body of an immediate threat and unleash the immune system defense. Once a pathogen has been ingested, the immune system produces antibody against it that work without immune system components to destroy the infection and end the sickness. Acquired immunity. Acquired or specific immunity is the immune response, immune protection we have learned and built over the course of our lives, resulting from exposure to illness or disease. When pathogens are introduced into our body, our immune system learns to target this antigen in the future by making new antibodies which protect us from an infection should the pathogen try to re-enter. Acquired immunity include active immunity, passive immunity, and active and passive immunity also come with artificial and natural immunity. Leukocyte, white blood cell protecting the body against infection and foreign substance. White blood cells that are created in the bone marrow and present in the bloodstream include neutrophil, basophil, eosophil, monocyte, lymphocyte, etc. Immunoglobulins. Immunoglobulins are specialized proteins linked to pathogens that protect the body from disease and illness. B cells create immunoglobulins which perform a variety of tasks such as identifying infection, removing antigen, recruiting immune cells, activities, complement, neutralizing poison. Immunoglobulin A, D, E, G, and M are the 5 distinct antibodies basophil produce. Immunoglobulins is a Y-shaped structure with four chains, with 4 chains, 2 heavy and 2 light. It's composed of 5 distinct varieties. Ig is the most prevalent type and its only antibodies cross the placenta from the pregnant woman to fetus, protecting it from diseases it has yet encountered. Immunoglobulins vary due to polypeptide synthesis. IgA is essential for protecting mucosa surface, including those in the mouth, from infection. IgM is composed of 5 regular immunoglobulins linked to their bases when exposed to an antigen. IgE is the antibody that causes allergic reaction, and parasitic infection is low in healthy people. May be a B cell antigen receptor. IgG is a rare antibody with unknown purpose. Self-recognition and tolerance. Tolerance is the antibody's ability to distinguish between self and non-self using antigen through immune system. Immune system recognize self-reproduced antigen as non-threat, limiting assault to non-self-produced cell. Self-recognition is dependent on 2 components: the human leukocyte antigen, gene complex, and pair of surface protein, and major histocompatibility. And HT1 molecule are present on all healthy nucleated cell. The immune system recognizes healthy cells as self, but when a cell contracts a pathogen-specific protein antigen attack to MHC1 molecule and appear on the cell surface, alerting it to foreign non-self-produced cell, and this infected or cell must be killed along with the pathogen. The immune system cannot respond to foreign antigen at a constant level, as the intensity of reaction depends on how similar the self and non-self antigen are to one another. Self antigen elicits less response than distinct antigen. Hypersensitivity, an aberrant immunological reaction caused by repeated exposure of the immune system to an antigen that ordinarily would not have induced an immune response, can cause self-tolerance to fail. The body reaction to a chemical rather than a substance itself is what causes the harm, which can subsequently result in allergies to outside agents like peanuts. Immediate antibody mediated, immune complex mediated, and cell mediated hypersensitivity reactions are the four primary kind virus immunological response, such as allergies in type 1 and multiple sclerosis in type 4 are linked to each type. Type 1 instantaneously response brought by IgE antibody allergies are one example of them. Type 2 cytotoxic response mediated by IgE or IgM antibodies mediated reaction or even blood transfusion are example of type 2 behavior. Type 3 immune complex mediated, which can result in inflammatory reaction, for example rheumatoid arthritis. Type 4 cell mediated cellular response mediated delayed reaction, and type 1 diabetes is one illustration. Autoimmune disorder. Autoimmune disease can be caused by the immune system erogenically targeting healthy cells, leading to illness. Although our immune system is meant to shield us from illness, infection, there are times when it can work against us. Lupus and rheumatoid arthritis are two autoimmune diseases that can have varieties of effect on the body region and organ. Lupus is difficult to diagnose because it can be mistaken for other illnesses. SLE is the most prevalent of four lupus forms. Inflammatory tiredness, and kidney damage are all potential effects of lupus, which can harm more than one area of body, including the skin, joint, and nerve. Although there is currently no cure to lupus, it can be treated with steroid injection and inflammatory drugs. Rejection of transplanted organ. Cell tissue or organ can be transplanted from one person to another to replace damaged organ. However, the immune system acts as a barrier to the process due to its efficient system, which regards the transplanted organ as a foreign agent by attacking it, since it is just non-self tissue. Typing is cause to check for antigen compatibility between the potential donor and recipient, but rejection is still possible though. Immune response. When a pathogen is present, two responses, primary and secondary, take place. The initial response occurs when the germ is contacted. It takes time for B cell to identify the pathogen and take antibody, allow the infection to create its symptom. At this moment, memory cell will start forming to recognize the pathogen. It is surface against agent. Immunological memory. Immunological memory is the immune system capability to react to a pathogen it has already been exposed to. The initial reaction occurs when the pathogen is contacted for the first time. but memory cells are produced to record the right antibody on a subsequent response. Memory cells recognize the pathogen and generate more antibody, which frequently combats an infection before symptoms appear. The immune system of the body is exposed to a weakening of harm vaccination. The pathogen during the vaccine leave an inactive vaccine come in wide variety. Live vaccines are made from bacteria and virus that have a tiny dosage of the virus bacteria administration, and this multiplies in the body development enough bacteria to trigger an immune response and for the antibody to undergo simulation before encouraging an active instance that illness. Inactive vaccine typically need repeated dose, since the first dose just serve to prepare the body for the second dose, which does not provide immunity. Immunological memory is what happens once that knowledge is stored in immune system. Serious infection can be prevented by vaccination, since viral disease cannot be treated with drugs. Vaccination benefits. Vaccine offer different defense against several illnesses, including those that are resistant antibiotics. Globally, vaccination and immunization program provide several advantages, such as lower healthcare costs, decrease in antibiotics resistance, increased life expectancy, cancer prevention, economic growth, and empowering women. Cancer prevention and empowering women. According to American research, older people who have had flu vaccine have 20% reduced risk of developing cardiovascular, cerebrovascular illness, and 50% lower risk of death from any cause than those of the same age who have not received the shot. Growth in the economy can be free. Herd immunity. When large population is inoculated or to immunized to disease, typical indirect defense known as herd immunity emerges. The risk of infection spread is decreased, since there are fewer people who can contract the illness. Even the misery is unlikely to spread when the patient enter the room with others who have received the vaccine. Herd immunity protects those individuals who are unable to get immunized, such as new baby and those with weak immune system, by limiting the spread of infection disease within a population. Herd immunity issue includes some people not eliciting an immune system contracting an infection before the vaccination has had a chance to take effect, and people who refuse to vaccine for moral or religion reasons. The pathogen being immunized against may not be recognized by the immune system and may come in a variety of forms with various antigens. The infection may also quickly evolve. Vaccination uptake. Vaccination related health concerns have increased, leading to false information and exaggeration tales. The Center for Disease Control Prevention states influenza vaccine reduce the risk of illness by 40 to 60%. Many people still choose not to receive the flu vaccine. The fear of side effects, although doctors and chemists may dispel this fallacy, but some people often trust non-expertise like friend, family, co-worker, etc. Disease rates have decreased because of childhood vaccination, and World Health Organization has declared UK free. In conclusion, I have discussed the function of various immune cells and immunoglobulins, the human immune system, non-specific disease, defense, the third line, and defense, including acquired immunity and sensitivity to antigen, self-recognized tolerance to one's own tissue, and rejection of transplant third organ, as well as 2 specific immunity disorder, including rheumatoid arthritis, lupus, and multiple sclerosis. The demographic describe the many forms of acquired immunity, such as passive, active, artificial, and natural immunity. Discuss the concept of herd immunity and immune response to immunization, including immunological memories. Thank you.